Hi there. Today I'd like to demo the volumetric component within TouchDesigner that I've developed for powering my volumetric display art piece called Primitive Obsession. The component renders textured sops to a 3D texture, which can then be passed to an output component for display. Here I have a colorful Suzanne, which is rotating and scaling, and we can see it output on this simulator of a single module from Primitive Obsession, which is a 20 by 20 by 20 grid of LEDs. This first version of the volumetric component has configuration options for texture size and anti-aliasing. Currently only cubic textures are supported, but the rendering method used can be generalized to any output texture size. Zooming inside, we can see how this works. The method is based upon instance rendering, where we slice the model into thin sections with as many slices as we have Z layers in the output texture. For each slice, we perform traditional rasterization, and then we composite the slices into the 3D texture. If we only perform this rendering from a single camera axis, we lose geometry when faces rotate such that their normals are perpendicular to the camera. To fix this, we render once looking along X, once looking along Y, and once looking along Z, and then we max composite the resulting texels to get the output texture. This is cheap to compute, even for large raster dimensions, and you can see that if I scale this up, I'm still achieving a very respectable frame rate on an M4 MacBook Air. All right, so let's next take a look at the artNET output component. It's driven by this docked table dat. And you can see an entry in this table for the controller simulator, which you saw earlier. In the table, you can configure the IP address of the controller and the port, and a sampled region, size, and offset, together with which slices from that region will be sent to each controller. The universe stride for this output is set by universes per layer in the component parameters. The component supports configuring gamma-based color correction as well, which is useful for commodity LEDs which have highly nonlinear output response. Within the component, the replicated output component internally uses a DMX out chop, and in a future version, I might customize this so that you can maximize frame rate for setups where your LEDs per output channel is not evenly divided by the maximum number of LEDs per universe. Both of these components are open, and feel free to dig in and customize to suit your project. Thanks for watching.